This is our first ever video for Honors Chemistry, so yay! My iPad is all fixed now, so yay! I have attached on the blog a copy of the slides that I'm going to go through. So I know that in class we very briefly talked about... That's Whitney. I know that in class we very briefly talked about mixtures and mixture separations, and that was the reason why you did the chromatography lab on Friday, because that's one way that we can separate mixtures. Today I want to talk briefly about mixtures again, the two types, and then I want to talk about elements and compounds. So if you would open up your slides and kind of follow along with me through those, then I think that it will be a lot easier to go through this video. On the second slide on the PDF, I just wrote about your objectives. So like the main thing that I really want you to learn is that you would be able to identify or differentiate between homogeneous and heterogeneous mixtures. And then I would also want you to be able to tell me the three ways that mixtures can be separated. Now mixtures are just a physical blend of at least two substances. So I always think of a salad. That is, I guess, my go-to example of a mixture. It's going to have variable composition. So a mixture needs to be made of at least two different substances, and then it's going to be varied in composition. And there are two types. There's homogeneous, and then there's heterogeneous. In a heterogeneous mixture, that's where it's not uniform in composition. So a salad would be a really good example of a heterogeneous type of mixture. What I mean by that is, if you take your fork and you're about ready to take a bite, in one bite you may have 3 pieces of lettuce, a tomato, and a crouton. But in another bite, you may have 4 pieces of lettuce, a tomato, and some cheese. Maybe you don't have the crouton at all in the second bite. So each time you take a bite, you're going to get totally different things. That's a heterogeneous mixture. Another really good example of a heterogeneous mixture would be like a chocolate chip cookie. You take your first bite, maybe you get 2 chocolate chips, or you take your second bite and you get 4 chocolate chips. It varies every single time you take a bite, which that bite could just be like our sample. So it's not uniform. The second type of mixture is called a homogeneous mixture. And a homogeneous mixture is where it has the same composition throughout. So a good example of this would be like a Kool-Aid solution. Whenever you stir in the sugar, you have water and sugar, and then there's a little bit of food coloring in there as well. But all of the sugar should be equally distributed throughout that water. So because of that, I would say that it's a homogeneous mixture. But it's sugar and water, so it has to be some type of mixture because both of those things are keeping their own properties. Another good example of a homogeneous mixture would be air. If you took a tiny little sample of air, like let's say you had like a little vial and you just took a small little sample, it should have 70% nitrogen. It should have a certain percentage of oxygen, a certain percentage of carbon dioxide. So you'll see that if I take one sample and I'll see all of those percentages of elements in it, if I take another sample, I should have the exact same amount of nitrogen, carbon dioxide, oxygen in air. I should have the exact same amount. So I would say that that would also be a homogeneous mixture. One really important thing about mixtures is that they will maintain their own properties. That's Cody. With mixtures, they maintain their own properties. So let's go back to the salad example. Your lettuce tastes like lettuce. Your tomatoes taste like tomatoes. It's not going to mix up. So your lettuce is never going to taste like tomatoes, just like your tomatoes are never going to taste like lettuce. So they maintain their own properties, and that's really, really, really key in terms of talking about a mixture. Now, if you go to the next slide, this is something that we already talked about in class, so I'm not going to go too much into detail about it. We know that mixtures can be separated by physical means, and you can, if it's big enough, like a salad, you can actually physically take pieces out of a mixture, and that's completely fine. But for an example, like we talked about yesterday, there's a mixture of sand and sugar. You're not going to sit and physically take out little particles of sand because you're probably not going to be that accurate. So we said that there were 3 methods. One was filtration, one was chromatography, and then the third one was distillation. And you saw what chromatography did yesterday. We talked a little bit about filtration yesterday, and on Monday I'll talk a little more about distillation. So I would just want you to know those 3 methods. It's nice if you know how to describe them, but I don't think that that's anything that you should really focus on or worry about. The next part that we're going to talk about are elements and compounds. And I wrote some objectives for you that I would want you to explain the differences between an element and a compound. And then I want you to compare and contrast elements, compounds, and mixtures, because all 3 of them are different. So if you go to the next one, substances can be one of 2 things. They can be elements or they can be compounds. And specifically, you should write down that they're pure substances. So pure substances can be elements or they can be compounds. So on the bottom of that slide, I wrote, what do you think the differences are? And I drew a picture of a compound, and then I have a picture of an element. The picture of the element, you'll see that all of them are just spherical. They're all the same color, so it looks to me like they're all the same atom. If you look at the compound shows that you have 2 different types of atoms. You have blue squares and you have red circles. But there's this little black stick that goes in between that blue square and that red circle. And that should indicate to you that there's a bond. So elements aren't bonded together, but compounds, there's 2 atoms that share a bond. So let's go to the next slide. An element is the simplest kind of matter. It can't be broken down any further, and it's going to maintain all of its properties. So an element contains all of one type of atom. So if you go back to the previous slide and you look at that example of the element, it shows that in that box there's nothing but these little red circles. And that's to show you that an element is only composed of one type of atom. If you go to the compound, a compound is something that's made of 2 or more different types of atoms, and it can only be broken down by chemical means. That is super important that you know that for a compound. Let's compare that to a mixture, though. A mixture can only be broken down by physical means, because mixtures aren't bonded together like a compound is. So mixtures are only separated by physical means. Compounds only separated by chemical means. Okay? So compounds have completely different properties than their original elements. So for example, let's say that we had carbon dioxide. Carbon dioxide is made up of carbon and oxygen. If we broke that apart, the carbon atoms would act differently, and the oxygen atoms by themselves would act differently. But their properties will change when they're bonded together. So carbon, again, acts differently when it's all by itself. Oxygen will act differently when it's all by itself. But when you bond them, they make completely different properties. So that's what I mean when I say that they have different properties than what they were originally made of. Compounds, again, have a bond, so they are chemically combined. And mixtures, again, not chemically bonded. So the next slide I tried to compare compounds and mixtures. Compounds, we know, are made of more than one kind of material, so it has to be made of at least 2 different types of atoms. So compounds have to be 2 different types of atoms. Mixtures need to have 2 different substances as well. But the big difference is that compounds are bonded, mixtures are not bonded. Another big difference, compounds are separated by chemical means, mixtures are separated by a physical change or physical means. Compounds also have a definite composition. So what that means is, if we had a glass of water, all of the molecules or all of the compounds of water in my glass will be H2O. All of them look identical. If I separated them by chemical means and I looked at all of those little components of H2O, they'd all look the same. But in a mixture, like for a salad, for example, the lettuce doesn't look like the tomato, and the tomato doesn't look like the crouton, and the crouton doesn't look like the cheese. So they all have a variable composition, okay? If we go to our next slide, I tried to give you 3 examples for you to determine if something was an element, a compound, or a mixture. So if you look at A, you can see that you have red circles, and they're really, really close or touching to 2 little yellow circles. So what do you think that would be? Do you think that would be a compound, an element,